This is a topic that's very interesting for me because I'm an infrastructure guy. I'm a reformed software developer. I apologize to any software people. I believe now that you have to actually be involved in everything in order to actually deliver successful systems. So I'm a little bit on the database side, a lot more on the infrastructure side. I don't know anything about networking because networking people are a special breed. They like sleep under the stairs and they eat pizza. You just feed it to them through the stairs. There's a few key takeaways from this session, okay? Firstly, long-running servers suck. Really, absolutely suck. Hands up, anyone who still has servers in their company older than 1 month? Yeah, pretty much everyone, okay? I used to work for a company that we actually deployed Windows 2003 servers back in 2008, and I can tell you they're still in production today. Windows 2003 is still in production in some companies, okay? People basically remote desktop onto the servers and they install things by hand, by downloading binaries from the internet and so on and so forth. It's a really bad idea because no server is the same and you can't guarantee that what happens in your development environment or your staging environment or your QA environment is the same as what happens in production. Another question. Hands up who uses OS X, a MacBook, locally. Hands up who uses OS X in production. Right? So think about what we're doing. So, because long-running servers suck, there was an idea in 2013 by Chad Fowler. He wrote a blog post called Trash Your Servers and Burn Your Code, Immutable Infrastructure and Disposable Components. Now, this was a talk basically around the fact that immutable infrastructure was the way forward. We created our infrastructure once, and if we needed to change our infrastructure, we didn't actually make any changes. What we did is we brought up new infrastructure. Now, this is very prevalent in the cloud because it's very fast to provision systems in the cloud, and it's very cheap. It's cheaper, should I say, not very cheap. It's cheaper to provision systems in the cloud. If you have physical data centers, this is a little more difficult. Okay, obviously, if you run virtualization in your physical data centers, it's a bit easier. But if you still run physical servers now, to bring up a new server takes a little bit more time than it does in order to change the server. But functional programmers decided that maybe immutable is not actually the correct terminology for this, because for it to be truly immutable, you would need like a read-only file system. No files would be written locally. No one could SSH into the boxes or RDP into the boxes or so on and so forth. So they were like, it's not really immutable. So a discussion happened on Twitter for, I think, over the course of maybe 6, 7, 8 days by a few different people. And they said maybe disposable infrastructure is actually the better terminology for it. So by disposable infrastructure, they means that when it's created, it has a lifespan and it's okay to destroy. You don't have to hold on to it very easily. So I'm going to give an analogy to think about this is to treat your servers as cattle, not as pets. Okay, I apologize to anyone who has a farm, okay, because you don't take this well. And I apologize to anyone that has any religious beliefs about cows. I gave this same talk in India, and I actually used this same slide, and I didn't, at the time, remember that cows were sacred in India. So I'm telling people, it's okay to kill cows. That's not what I'm saying. I promise you I'm not telling you it's okay to kill cows. What I'm saying is that when you have cattle on a farm, you don't give that cattle, that specific individual cow a name. It has a number, it has a tag, it has something like that. The same as servers. When you have servers that were manually created in 2006 and are still in production today, they have like very meaningful names like Event Horizon 01 or SQL Database Production 01. They have a very specific meaning, and if it goes down, all hell breaks loose. Okay. Unfortunately, if a cattle dies, one of the herd of cattle dies, the farmer just goes and gets a new one. That's disposable infrastructure. You think of it in terms of that. So how does continuous delivery come in here? Continuous delivery it's been around for a long, long, long time. Right? It's not new. This is not new stuff I'm telling you right now. I'm trying to combine the worlds of infrastructure development and software development. And those software developers have been doing continuous integration and continuous delivery for a long, long time. Like Martin Fowler wrote a blog post way back in like early 2000s about continuous delivery, continuous integration. And then Jez Humble has been pushing continuous delivery for a long time. But if you look at it, nothing here suggests that it's specifically for application code. Okay, so the definition, and you can go and get this on Wikipedia, this is the standard definition of continuous delivery. Continuous delivery is a set of practices and principles aimed at building, testing, and releasing software faster and more frequently. Okay? Software as a whole. Okay? Doesn't say web application, or it doesn't say an API. It's software as a whole. And it takes a lot of pieces of a puzzle going together to create working software. So you can take all of continuous delivery and you can apply exactly the same principles as you can to infrastructure code. So who's an infrastructure developer in here? Who works with infrastructure daily? And who works with writing application code daily? So it's pretty close in how they do. And the people who write application code, do they write infrastructure code? And the people who write infrastructure code, do they get involved in software code? A few, okay? So the words are starting to combine. We no longer have this separation because of the word DevOps, okay? I'm not going to go into DevOps because I will go ranting, and this is recorded, and we don't want that. So continuous delivery has a number of principles, okay? You can go and read them, and you can say what's going on and stuff like that. But the main point of continuous delivery, it has 4 practices. 4 key practices, okay? So number 1, you build your binaries once. Build your servers once. You can take it and translate it directly to infrastructure. Build your servers once. Look, it's talking about immutability, disposability from the outset. Number 2, use precisely the same mechanism to deploy to every environment. Please, if you only take this, if you take anything else away from me, don't do a Docker deploy to dev and then do a different type of release to production. You must deploy the same way to every environment so that you practice that deployment. It's really key. That's extremely key. Number 3, you must smoke test your deployment. I have brought down many applications. I have caused many problems many times because I followed the release mechanism and then I've gone, great, it's released. And the next thing is an hour later, my phone goes, it's like, did you make a release today? Yeah. This part of the system is burning down. Okay? You must check what's going on. And I'm not saying you must spend 5 or 6 hours in order to go through it. You can automate your smoke tests. Okay? You will have a key specific part of the system which you know is what makes you and your company money, and you smoke test that because if you cause an outage in that area, it will cost your company money. And lastly, and most importantly, if anything fails, stop and fix it immediately. You can't let it grow and get worse and worse and worse. You must fix it there and then. It's really important. Anyone read the book, Continuous Delivery? Okay, go and buy the book. Okay, I am pretty positive that your companies will allow you to buy a copy to share amongst your team. Okay, I'm not telling you that you must go and you must read it end to end across an entire weekend. In fact, if you do that, you will probably want to quit IT straight away. Okay, you take small pieces of the book every so often and you digest it and you think about how you can bring that into your environment, into your culture and into your process. Small pieces at a time. Because that's the whole thing about continuous delivery. It's all about continuously improving. Okay, you can't just sit down in an office with lots of people and your boss and go, okay, how are we going to achieve continuous delivery? And then you write 10 things on a board. And then after every day you check them off and after 10 days you go, great, we're continuously delivering. It takes a long time, it takes a lot of process, and it takes a culture change as you go. We're going to use 2 tools here today, okay? We're going to use Terraform and we're going to use Packer. They're by a company called HashiCorp. Radek gave a talk maybe 2 talks ago around Terraform. So I'm not going to go over the same Terraform stuff. It's going to be much more higher level around why we should use it and how you should bring it into your environment. It's no coincidence that I'm talking about these two tools because up until very recently, I also worked for HashiCorp. This is not a sales thing, okay? I don't care if you use these tools because I can legitimately say I no longer work at the company now, and you can use whatever tools you want. But even since I've left the company, I still contribute code back to the tools because I actually find them very impressive and very useful. I must admit, I wasn't at Radek's talk. Sorry, Radek. We're going to quickly talk about what Terraform is. Terraform has a number of providers. Okay, providers are like cloud interactions or software as a service or so on and so forth. And then inside each cloud provider, you have a number of resources. So like an instance, a subnet, a VPC, a load balancer, etc., etc. Okay, so you specify in a DSL, a domain-specific language, how your infrastructure looks, and Terraform will apply that. How it does that, it uses graph theory. Any mathematicians in the room? Yeah. So you're probably no graph theory. This is graph theory for me. Nodes and edges. Done. In actual seriousness, I apologize. I'm not, no math jokes. Nodes are like pieces of our infrastructure. Okay, so like an instance, a security group, a load balancer, a subnet, a VPC, okay? Edges are the relationships between those systems, okay? That's as much as I personally believe that I need to know about graph theory for Terraform, okay? I would love to be clever enough to understand more graph theory. I will leave that to the experts. But what Terraform does is Terraform actually uses a cyclic graph because it knows the relationships and the order in which the relationships need to happen. Okay, so it knows that A, let's say A is a VPC, has to be in place before B, which is a subnet. And B has to be in place, a subnet, before C, an instance, because there's an order in which things are created in Amazon and any other generic cloud. There's a lot more information on this YouTube talk at the bottom, and it's by Paul Hinsey, who still works at HashiCorp, and he's a director of infrastructure. It's a wonderful talk on that infrastructure. Because of graph theory. So go and have a watch if you want. So we're going to just write some code. It's much better. You don't want to listen to me all day. Let's mirror my display. There we go. Oh, wow, you can even see it. So before I came in, I created an AMI. Okay, I used Packer to create an AMI, and I'm going to show you what that does. Okay, an AMI is a machine image in Amazon. Okay, so it's predefined how the image is created, so what applications are on it, the configuration that's on it, and so on and so forth. I like to create AMIs. AMIs are very dodgy territory for a lot of people. I tweeted once before saying, I love the fact that I can create a new AMI, release that AMI, bring up new instances on it, and they said, hey, 2006 called, and they want their golden images back. Okay. For me personally, I believe that's okay. Anyone use Docker containers? These are my Docker containers. So I have an AMI and I have an AMI ID. Apologies for those at the back of the room that can't see the bottom of the screen, but I'll make it better. And we can see, if we go to Amazon, that we have an AMI. Just one single AMI, nothing else. And I can show you what is in that AMI. Very, very, very simple. Okay. So I have a template.json file. I need to raise the size of this. 1 second. Font 20. Oh, not 120. Where? Oh, wow. It's almost as though they're JetBrains people in the house. Yeah, I know there are, sorry. This is Goglang by JetBrains. I love this tool, okay? The reason being is when we write some Terraform script, there is autocomplete for Terraform. Okay, means I don't actually have to know all the syntax, and it makes me look better in my demos. So we have some variables that we pass in, and Packer has a list of what's called builders. Okay, builders are for different areas. Okay, so you have Amazon EBS instances, Amazon instance type application stores. You have Triton, which is our cloud adjoint. You have Chroot applications. You have EBS volumes, and so on and so forth. Okay, so there's a list of different builders if you go to Packer.io, and you can have a look at what it is. Okay, and a builder in this case takes an Amazon EBS instance in a specific region using a specific source AMI. I pass in that AMI ID. I give it some SSH username and password. Whether it needs a public IP address so that people can actually access it or not, it doesn't really matter in this case because it's an AWS instance for Packer. And then we give it some AMI names that comes out the back of it, and we give it some tags. Okay. Now, you don't have to follow this code specifically, I promise you. This is like just basic level code to show you what it's doing. The most important piece of information here is version. Okay, because I like to version all my AMIs, and I like to give them other tags like operating system and component and so on and so forth. Okay. Version will become very important later when we go into Terraform. After a builder brings up an instance, provisioners are then ran on the instance. Okay. So in this case, I'm actually installing NTP and Nginx, okay, just to show you that it can do some things. And then I copy some files, an Nginx config, an index.html file, and then I'm actually just setting up some very simple Nginx configuration. Really basic, simple stuff. And I'm enabling Nginx so that when the instance is booted, Nginx will be running and the application server will be running. Okay, how do I get out of presentation mode? I will leave it in, it's fine. It's easier if I leave it in. So I have the application server up and I have it running. And I can then use that application server going forward. In order to do it locally, what I would say is, firstly, I make validate. Okay, I always validate my Packer templates, actually. I always validate my Packer templates, okay, because it's JSON configuration and you can sometimes get in some problems with it, okay? So I can run the command make validate, and it's actually going to take the Packer template and it can tell me template validated successfully. Of course, this is just a command, so I can hook this into a CI tool. Okay, whatever CI tool you want, TeamCity. I'm not being paid, I promise, I really promise. But you can hook this into any CI tool that you want. Okay, this will actually be, the flow would be, developer changes the template, they'll send a pull request, the CI tool will check out the pull request, it'll run the equivalent of validate the template, it'll post saying, template is validated successfully, you can merge it through into the master. Okay, there's a flow for your AMI templates. Okay, and I just have to bump the version, if you just give me 1 second. How do I actually get out? Shift, exit. I don't know. Yes, I'm out. It's fine. We're good. We're doing okay. We're all right. It's okay. And what I'm going to do is I'm just going to pretend that a developer has created a new version of this AMI. Okay, and we're going to save it. And of course, because I'm really lazy, I'm going to just bump that file as well, just to show you that there's a difference. Okay, I'm going to show that I can go back in here. Toggle. I actually leave it. Doesn't matter. So at this point, I can go back to command line, eventually. And I can make AMI. All I do is I use make files for everything. I'm very lazy because I don't like to run the same commands again, so I like to wrap it very short. Okay. And just to show you, if I cat my make file, you'll just see that everything is in my make file. And I even have help so that when I type make tab, it gives me the AMI, it gives me all the targets available. I am lazy. What can I say? So we're going to make the AMI, and that's going to go off, and that's going to create a new version of the AMI, which is going to be 1.0.1. Easy. So let's go back to Terraform land. Any questions so far? Anyone still awake? Excellent. At least people laugh. That means they're awake. So I have a Terraform system called, of course, it's called demo. This is to show you that this is not production code. You can take it, you can try it, but there are some very interesting ways of doing things in here. Firstly, I use modules everywhere in Terraform. I no longer work for HashiCorp, so I can give my direct opinion on modules. For me, modules are in a level of encapsulation. Okay, so for example, I like to encapsulate everything to do with a VPC. So networking, subnets, route tables, etc. That's an encapsulation, and what happens inside that, sometimes the developers that I work with don't need to care about. Only the people that actually need to understand the module can go in and change the module. Question? ADSS. Oh, yes. So the question is, the point is, you do have to care about what's happening in here when you use AWS aliases. 100% correct, okay? I would make sure and tell you at that point that anyone who's using any cloud should understand what's happening in the cloud per se, not just like the application level. They should have a general knowledge of like VPCs and how they relate to each other. They just don't need to know how this route table relates to that route table, and that route table represents the subnets and so on. So yes, I agree with you 100%. So in this case, I'm going to create an AWS resource. I'm going to create a VPC, which has things happening inside it. What's actually going to happen in this case? It takes a top-level CIDR block. It's going to create 3 private subnets, 3 public subnets. It's going to take a list of availability zones. But we don't know what those availability zones are. We'll talk about this in a second, the data sources. I can't remember, I don't really know if Radek went into it. We're going to create a VPN. Please do not use this VPN module. Okay? This is an open VPN module that creates one AWS instance that has no certificate. It uses the public IP address only, and it hard codes the password. So we'll forget about that. Which is password. Have you seen my code before? No, but this is just to show you that we can connect to a VPN. There are much better VPN modules out there. This took me about 20 minutes over 2 beers to write and think, this is a good idea. Okay, then we create an application tier, which is an auto-scaling group, a load balancer, some launch configuration based on an AMI ID, and it spins it up across a number of subnets and a number of availability zones, and it uses the SSH key. We'll come to this data source in a second. Firstly, I told you availability zones. Availability zones differ between AWS accounts. So my account in US East 1, for example, could have access to availability zone A, B, and D. Your AWS account could have access to B, C, and E. Okay? So by hard coding these values, it would cause you problems if you downloaded it and tried the code. So we had this idea within HashiCorp of let's create some data sources that we can actually query Amazon and see what's available for us. So under the hood, this is making the call describe availability zones, and then it brings back the list of all availability zones within a specific region for your account. Okay? Really good. Data sources are wonderful. They really are. And of course, because of that, we can use data sources on AMIs. Now we get to the magic of my demo, okay? Because I am creating an auto-scaling group that has 3 instances running, okay? By default, it will have 3 instances of 1.0.0, okay? So when I deploy my new AMI and I next run the Terraform configuration, it's going to change the launch configuration, and the next servers come up with the next version of the code, and so on and so forth. And we can orchestrate that in and out. So let's go and have a look. Let's see if we can get this demo running. And we can see, by the way, the Packer build is finished now, and we have a new AMI at the bottom. I go back to Amazon, I refresh the page, maybe, and I can see a second AMI, hopefully. Really hopefully. Yes, very good. Wow, it's almost as though I tested this. So we're going to go back to the Terraform code. And firstly, we're going to say Terraform init. Okay. Since Terraform 0.10, Terraform split its providers out into their own repositories, and the Terraform init command basically goes off and gets the copy of the provider that you need in order to run. So we're going to Terraform init. Okay, downloaded the module. Very good. We're ready to move forward. Excuse me, it downloaded the provider. Next, what we actually have to do is we have to say Terraform get. Okay, because we have to go off and tell Terraform to download the modules that we require it to have. The modules so happen to be on my local machine right now. How long do I have? 25 minutes. We've loads of time, it's fine. We can like dance or something. It'll go off and it'll get all the modules, it'll bring them down locally. Because modules can be stored in their own GitHub repos or their own Bitbucket repos. And this is what I said about a networking module or a VPC module. You can give the networking team access to make the changes, and that's an API for the development team to work against. Okay, really useful. For now, Terraform get is just going to create symlinks, nothing else. Terraform get. And it's downloaded and got the symlinks. I had them already downloaded. So the next thing is we want to build a graph. What it's going to do, again, I'm sorry if you've been to Radx talk, this is basic stuff. It's going to take the current state of what it has locally and compare it against what's in my AWS account that I'm targeting. Okay, and it's going to tell me the differences of what it's going to do. In this case, it's going to create 35 new resources. As you can see, I have nothing in Amazon right now. Okay, it would tell you that none would change, or it would change you one change, two to destroy, so on and so forth. There is nothing there. And you can see everything that's there, egress, ingress, so on and so forth. And now we're just going to say a quick prayer to the demo gods. And we're going to apply the changes. So while that's happening, I really like to point out, okay, you don't need to do this from your local machine. Again, because it's just simple commands and it's passing variables into Terraform, okay, you can bring this exact same process out to your CI tool. Question?
You have to use the state.
Okay. So I was going to get there. You're like a great assistant. I like this. So the point is that if you want to move it to CI, you must use remote state. I would like everybody, when they're using Terraform in general, to always use remote state. Please, for the love of God, do not keep state locally on your machine. And even more, do not check it into your source control repo. One of my pet peeves about Terraform, even after all the years of working with it, is it still stores some secrets. Okay, so for example, if you create an RDS instance, you actually have to give it a password and it may store that in your state. Okay, what we suggest, or what we always suggested when I worked at HashiCorp, is that you would have a code process that ran after the back of it and change that password. Okay, so do not, try your best and not store things locally. Okay. And then you can, as you say, you can put it in the CI tools. Okay. And the CI tool, you can always have your CI tool running a plan. And then if there's a diff, it can be a red build. Okay. If it's green, if there's no diff, it can be green and everything would go as expected. So it's going to create a lot of infrastructure for me right now. And I'm just going to show you CD Terraform. I'm going to quickly turn off the mirroring 1 second while I put in a key. I have actually put my keys live on the screen before. I really have. It's not a good experience, especially when you forget that they're actually your keys. Okay. Very good. Okay, so I can show you the screen again now. Terraform also has the ability to graph. Okay, because as I said, it builds a tree of everything that's going on. And because it builds a tree of everything going on, it actually gives you the ability to see what's happening in your infrastructure. Oh, it hasn't finished running the plan right now. But the graph would just be basically a list of JSON. But you can pipe that JSON through a PNG or dot files, excuse me. If I go and I show you an example, I usually like to keep an example here. Wow, I'm being killed on the internet. Come on, here we go. Terraform, demo 1, graph.pdf. It'll just take a second to download this because it's 29 kilobytes and we're obviously in the third world. But the most important thing is that you can actually see that it completely draws your infrastructure and it will show you the relationships between all the different pieces. This is graph theory. There's your nodes and there's your edges. And because of the ordering, that's your directed acyclic graph. Great. That's all you need to know about that. And then if we go back, we can see that it's actually creating some things. In this case, it's creating an auto-scaling group. The auto-scaling group has a capacity of 3. We have NAT gateways that are being created. We have VPN still being created, and so on and so forth. So it'll just take another minute or two for this to go through. Any other questions while it's happening? Could you use Terraform Vault for secrets? The answer is, I'm looking at somebody who still works on Terraform. The answer is no. There is no Vault data source to read secrets out of Vault into Terraform. Okay, it would be amazing. Hint, hint, hint. If people could do that. But I know that it's actually a lot more difficult because it's a co-process that has to shell out from Terraform to something else, and it would make life a little more difficult. Okay. It would be very good if you can do it, but there are other ways in which you can do it. Okay. Environment variables are a good way in order to do it. Okay, because then you don't have to actually put them in code. It can read them as environment variables, and you can use something like envchain if you're on Mac OS X, or something in order to read your environment variables that way. Okay, so there are ways around it, I promise you. There are much ways around it. And we have, at this point, some pieces of infrastructure. Okay, thank you, Lord, for that. So I'm going to log into my very super secret VPN. Don't hack my VPN. This is really important. What? Oh, it hasn't finished being come up yet. 1 second. It takes a second. It's slow. It's OpenVPN. Oh, it's OpenVPN. It's always a little bit slower. VPN. There we go. It's just initializing. As soon as that changes, then we'll actually be able to log into it at this point. The most important thing here is that we have 3 application instances. And if I was clever, which I wasn't, I would have tagged them with the version of the application in which they're running. Always do that. Always do that. That's a very key thing, because that doesn't really show that my demo works right now. But it will. It will show you in a second, if it ever lets me log in. Come on. Come on, little VPN. Oh, yes. Okay. It's very secure. And we have OpenVPN, and I just utter the secret password. I promise you it's not password. Just to show you that everything is actually behind a VPN. If I take this and I put it in the browser, you cannot get to it. You can get to it. Oh, and I'm connected to the VPN, of course. If I logged out, you wouldn't be able to get to it because they're in private subnets. Okay, but we can see if we go to the application server that this is version 1 of the application, and you keep refreshing. And you keep refreshing, and you keep refreshing, and you keep refreshing, and you're round robin in between servers, and it'll always be application version 1. So what happens if I go back to my code, and I change this from 1.0.0 to 1.0.1? Okay. Obviously, a CI tool is going to be pushing that number in for you. Okay. No manual updates, because what happens in a manual update is somebody's going to do that. Because people are stupid and we make mistakes. We're not machines. We're not designed to be perfect every time. But we push in a specific version and we go back to Terraform. And if we plan, what it's going to tell me is it's going to change the launch configuration and the auto-scaling group. Hopefully. Maybe. We'll soon see if my demo works. It'll just take a second. It refreshes the state to make sure there are no changes every time. But it's almost done. Changes, please. Come on. There we go. Okay, so what it's actually going to tell me at this point, it's going to change the launch configuration from one specific version to the next. And because of that launch, or because the ID changes, it's going to force a new launch configuration. When it forces a new launch configuration, it's actually going to change the auto-scaling group to attach to the new launch configuration. Okay? It's not changing my live instances. This is really important, okay? Because you can follow this process around and around and around and around and around without changing your live production instances, okay? You could be an application 1.0.1 in production, but your application, or excuse me, 1.1.14 in production, but your instances that are live are still in 1.0.0 because you haven't orchestrated a change of application server at that point, okay? So you can always be testing this flow without changing your production system. It's really important. And if we Terraform apply that, it's going to go and change it. Now, back to AWS. When it changes and it runs through, what we're going to do is we're going to go into the auto-scaling groups. Come on. I'm trying to tether from a phone that's from the UK to Russia with a VPN going into AWS servers in Ireland. Technology. It's amazing. And we can go to the AWS configuration and we can see that there are 3 instances running. And we can see that the instances have one specific launch configuration. Okay? And they're all the same. So what we're going to do, if it has changed, let me just see if this has changed. It's just about to finish. Let me just close this. It's annoying me. So we're going to pretend that, no, we're not going to pretend. We're going to pretend that worked. We're going to go, and we're going to try and delete that launch configuration. And it's going to fail. This is amazing. Launch configuration, where are you? I okay. So the issue is create before destroy, exactly that. ASG and its life cycle create before destroy equals true. Notice the IntelliSense that it just gave me there. Okay, it's amazing. Thank you, the lovely people who created this. And we're also going to go in and say create before destroy true. And then at this point, we're going to Terraform apply. I apologize for that demo failure. It'll get there. It'll work. It'll work. It'll work. It'll take a second in order to roll that out. But yes, the answer is you always must create a new launch configuration before you destroy the old one. Otherwise, it'll say this launch configuration is attached to the auto-scaling group. Okay, so I should have picked that up earlier. I apologize. But what we can do at this point is we can actually go back to AWS and just to show that we can actually do some interesting things. We're in an auto-scaling group right now. Okay, this is where Amazon make us a guarantee that if we ask for 3 instances of a service to be running, they will guarantee that 3 instances of a service are running. Okay, they're very good at that. This is why we pay them the money that we pay them. So we'll just go to the instances, and we'll just destroy one. Come on. And I'm hoping that it brings, there we go. It's created the new launch configuration. It's bringing up the new launch configuration in its place. So if I delete one of the instances, notice all the instances are still intact. Okay? It's very important. It hasn't changed any of my live instances. If you use instances directly, and user data and so on, and you change the user data, it will destroy your live instances. Please don't do that. Please don't do that. So let's kill it. Instance terminate. And what's going to happen is when it shuts down in the auto-scaling group, it's going to say, hey, there's an instance missing, and it's going to bring up a new instance in its place. Now, here's where you get into an interesting situation. 1 second, I'll come to you, okay? A new instance is going to be launched with the new launch configuration, okay? So there could be a chance that you have a system that has a number of images of A and a number of images of B, okay? So sometimes it's best not to always delete the old launch configuration. You can keep it and you can reattach it if you need to. Okay, this is where things get interesting. Why you should do this with like scripting and CI tools rather than doing this manually like I'm showing you. But there are tools that can do it. There is a really nice GitHub repository, okay, called AWS Missing Tools. Okay. I've been using this. As you can see, this was created like 3 years ago and updated. It's updated like once every so often, okay? And I've actually been using this repository for 3 years now. Okay. And what this tool does is of course it's a bash script. Every good thing starts with a bash script. And it basically says, hey, I want you to go through all the instances in my in my load balancer and destroy them one at a time and bring a new one up in its place. Okay. So if I have lost one of my instances of application server 1.0.0 and a new one of 1.1.1 comes up, I actually want to kill all my 1.0.0s and just bring them all into new versions, okay? Because I'm always pushing forward. I don't like application server sitting for a long time and so on and so forth. An example of that is in a startup. The startup has since gone bust, and it's not related to what I used to do, I promise. But every 7 days, I actually had an orchestration script that destroyed every one of the instances in my account. Okay. A server was only 7 days old. The other thing I used to do, which is one of my favorite things, is when one of my greedy little application developers used to SSH into a box, Ansible used to tag the AWS instance as dirty, and then every hour it used to destroy those dirty instances. Okay? Because we don't want people going in and manually changing things. So having these orchestration scripts in place means that we can always keep our infrastructure free of greedy little hands, and it can always keep us free and up to date with security patches and bug fixes and so on and so forth. And you can use this by just running AWS HA release -A, your auto-scaling group, and it will go through each instance in your auto-scaling group, bringing it up to it'll replace it. And of course, because the launch configuration is now 1.0.1, all the instances will be released with 1.0.1. Orchestration script, run it from your CI tool. Here's your automated release. Okay. You can do that in QA. You can do that in production. You can do that in a local AWS account. You can do it wherever you want. We're doing the same mechanism every single time. Just to go back to Amazon, if I show you our instances right now, you can see it's got a new instance in place. If I just go back, it's a little slow. Yeah, the instance is up, the instance is running. And 1 out of every 3 or 1 out of every 6 or whatever the round robin it'll be is I should get a 1.0.1. If I eventually refresh it enough, there we go, we've got 1.0.1. Okay, so we've actually done a live release of the most basic software. Welcome to DevOps. Okay, very critical. And we can show that just by creating an AMI, a new script going through, we can actually release it that way. Now, the interesting thing here is, because we have scripted the AMI creation, we can test the AMI creation, okay? There are some lovely little there's a lovely little tool called server script, or server spec. Okay, server spec allows you to create Ruby-style specs to test how your application server looks. So, for example, if I show you tests, spec, I can say, Nginx should be installed on the server, okay? Nginx should be enabled and should be running on the server. Port 80 should be listening on the server. You can say user X should be available on the server. It should have its home location set to this. You can put all of these different tests in place so that when you create the AMI, your CI tool will actually tell you that your AMI is fit for purpose, and then it will actually, once it comes out the other end and everything is good, you know that your AMI is ready for production. Now, I have like 2 more slides, I promise. I'm not going to bore you much more. Somebody laughed, so that means they are bored. I'm joking. Okay. Mary Poppendieck is probably one of my most amazing ladies who I've ever listened to, okay? She's been talking about the lean software movement for so many years and about how she was involved with 3M in the 60s when they were actually doing lean software development. And she asks us the question, how long would it take your organization to deploy a change that involved a single line of code, and can you do it on a reliable, repeatable basis? Okay. It tended to be that question always related to software itself, code. Okay? How long would it take me to make this bug fix in this application and deploy it to production? There is no reason why we cannot take that same statement and apply it to our infrastructure or our databases or so on and so forth. Everything is scripted. It's 2017. There is no need in order to be in hacky anymore. We have so many tools at our disposal. We have so many examples on GitHub. There's probably even AWS credentials checked into GitHub where you can go and test the servers. Okay? So take some of the ideas of conferences like this back to your organization and just try. Don't implement everything. Take one single tiny thing and implement it. Show somebody, and then they will want to make one small change after that. This can be measured, and you can measure this. I used to work at a company called OpenTable. This is called cycle time. Okay? Our cycle time at OpenTable used to be 7 weeks, okay? Which is relatively okay. Okay? I've known people that takes them months to put code into production. Okay? By the time we went through our entire process across 4 years, it took a long time, 4 years, a big organization, big engineering organization, 200 people plus. We got that down to 3 minutes. Just by measuring it. When you measure it, you can improve every single time. Thank you very much for listening to me. Please find me on the internet if you want any other questions or come up and have a chat with me at the end. Have a good rest of your day.
Thank you, Paul.